Students, now we are going to discuss the question. Derive the expression for maximum work in isothermal reversible process. Or this question is also asked, derive the derivation for work done in isothermal reversible expansion of a gas. Question may be asked in various ways, but the answer is same. So question is, derive the expression for maximum work for 2 marks, or derive the expression for isothermal reversible expansion of a gas. For that purpose, we are writing the answer. We are taking the help of this diagram. Look at this. This is the cylinder. The cylinder is having the initial volume, the gas, n number of moles of gas is enclosed within the cylinder, which volume is V1. Okay. Now this is the piston which is present here. It is having the external pressure P external and n number of moles of gas is enclosed inside it, and it is having the pressure P. Now what is the condition? It is reversible expansion. So reversible process means what? The process in which driving force and opposing force are differing infinitesimally, means very slightly. That's why what you are going to do here, we are decreasing the pressure. Initial pressure is P, is decreased to P minus dP. dP means very small quantity pressure is decreased. Suppose this pressure is 10, then we are decreasing it by 0.001, means that is the infinitesimal. Therefore, pressure is changing from P to P minus dP. That's why this piston will move in an upward direction, because external pressure is more, internal pressure is less. The condition is now reverse, because we are showing the reversible expansion as expansion. So our pressure is increased and this pressure is decreased. Means opposing force, opposing pressure is less. That's why it decreases to P minus dP. So initial volume V1, as there is a decrease in the pressure, the piston move in upward direction. This is the initial position. Now it reaches to here. So that is the dotted line I have shown. Now volume is V2. But for explanation purpose, I have drawn in upper direction in very large magnitude. But there is a small change in pressure. That's why change in volume, that is dV, is also very, very small. That's why d is very, very small. Okay. Now what is our derivation? dW is equal to minus P external into delta V. This is our equation number 1. Okay. Now P minus P external is equal to dP. What you have done? Pressure changes from P minus P external, and that is nothing but the change in pressure, that is dP. Therefore, we can write P external is equal to P minus dP. याला आपण interchange करू. We are going to interchange this term. So minus P external comes here, it become P external. dP comes here, so dP become minus P minus dP. Clear? ये एक्सप्रेशन में ये टर्म हम चेंज करने जा रहे हैं. P minus P external is equal to dP. So minus P external इधर आ गया तो क्या हो गया? पॉजिटिव P external. और ये पॉजिटिव dP इधर जाएंगे तो क्या होना? माइनस. इसका मतलब P external P minus dP. This is equation 1. This is equation 2. Now from equation 1 and 2, placing the value of P external in above equation 1, dW as it is. P external is nothing but P minus dP. That's why minus sign is there. P minus dP, and dV is as it is. So equation 1 and equation 2 is converted. dW as it is, dV as it is. Only we are placing value of P external. Minus sign is as it is. P external is P minus dP. After solving this, minus into P, so it becomes minus P, and it is multiplied to dV. Minus P into dV. Now this minus minus what become? It become plus dP into dV. Clear? As this is the derivation we have seen, this equation number 3. But you know that change in pressure is very small. That's why change in volume is also very, very small. dP and dV are very, very small. That's why dP and dV, these terms can be neglected from this equation 3. So dW is equal to minus P into dV plus dP into dV. As dP into dV is neglected, we can write dW is equal to minus P into dV. Now this is our equation number 4. Clear? After that, we have to get the maximum work. For getting the maximum work, we are integrating equation 4 by placing lower limit as a v1 and upper limit as a v2. Therefore, equation become integration of dw, integration p into dv, v1 as a lower limit, v2 as a upper limit, minus sign outside the integration. Clear? This is equation number 5. After that, we are going to consider the ideal gas equation. PV is equal to nRT. We want the value of P. That's why interchanging V comes here, it goes to denominator. So P is equal to nRT upon V. This is equation number 6. Now putting the value of P from equation 6 into equation number 5. So what is our equation? Integration of dw as it is, minus sign outside the integration, v1 into v1 lower limit, v2 upper limit. But in place of P, we are placing nRT upon V and dV as it is. Okay. Now, as it is having the n number of moles of gas, it is constant. R is the gas constant, it is also constant. And our process is isothermal, means temperature is also constant. So, constant terms can be taken outside the integration. Minus sign is integration outside. N is outside the integration, R is outside the integration, T is outside the integration. Now what is remaining? dw means integration of dw is w max minus as it is, N comes outside, R come outside, T comes outside. So what is remaining? dv upon V. V1 is the lower limit, V2 is the upper limit. After solving this, w max is equal to minus nRT as it is, dv upon V. Integration of dx upon x, x. Integration of dv upon V, V. Log of, here there is a integration v1 to v2, that's why lower limit v1, upper limit v2. Integration of dx upon x, x log of x. So integration of dv upon v, log of v. v1 is the lower limit, v2 is the upper limit. After solving this, you are getting w max is equal to minus nRT log of upper limit v2 minus log of lower limit v1. After solving this, w max is equal to minus nRT log V2 upon V1. So this is our equation we are getting. But we want to convert log to the base e to log to the base 10. That's why we are going to multiply this equation by means of 2.303. So the base of log is here e. We want log to the base 10. That's why we are multiplying this equation by 2.303. Therefore, final equation W max is equal to minus 2.303 nRT log to the base 10 and V2 upon V1. This is our equation number 7. Okay. So this is our main equation. This is the expression for work done in isothermal reversible process during expansion of gas. But this is related with volume. We want also related with the pressure. So we know at constant temperature P1 V1 is equal to P2 V2 by interchanging. So here V1 comes here. So V1 V2 upon V1. P2 comes here. P1 upon P2 means V2 upon V1 is equal to P1 upon P2. Now placing this value in equation 7, V2 upon V1. Okay. Now V2 upon V1 is replaced by P1 upon P2. Therefore equation 7 become W max is equal to minus 2.303 nRT log to the base 10 P1 upon P2. So this is our equation number 8. So this is the derivation we are derived for work done in isothermal reversible process. This is related with the pressure and this is related with the volume. So what is the equation? W max is equal to minus 2.303 nRT log to the base 10 V2 upon V1. For volume, for pressure, W max is equal to minus 2.303 nRT log to the base 10 P1 upon P2, V2 upon V1, P1 upon P2. So it is very, very important for solving the numericals. When you are considering this, here for derivation, we have taken the derivation. Clear? हम जो डेरिवेशन डिराइव करने जा रहे हैं, डिराइव द एक्सप्रेशन फॉर मैक्सिमम वर्क, ये 2 मार्क्स के लिए पूछते हैं, कभी कभी 3 मार्क्स के लिए पूछते हैं. और डिराइव द एक्सप्रेशन फॉर वर्क डन इन आइसोथर्मल रिवर्सिबल एक्सपेंशन ऑफ गैस. सो दिस क्वेश्चन का आंसर लिखने के लिए हम इस डायग्राम की हेल्प ले रहे हैं. डायग्राम में पहला वॉल्यूम है V1, n नंबर ऑफ मोल्स ऑफ गैस है, वो एक्सपांड हो रहे हैं. कैसे? प्रेशर हम कम कर रहे हैं. कैसे? P से P minus dP. That's why change in volume is very small dV. So गैस यहां से यहां तक एक्सपांड हुआ और रिवर्सिबल है इसलिए बहुत छोटी क्वांटिटी है. फिर भी डेरिवेशन क्या आएगा, dW माइनस पी एक्सटर्नल इंटू dV. सो इसको इंटरचेंज करेंगे, P माइनस पी एक्सटर्नल इज इक्वल टू dP. क्लियर. सो इसको इंटरचेंज किया, माइनस पी एक्सटर्नल इधर आ गया तो क्या हो गया पॉजिटिव पी एक्सटर्नल, dP इधर आ गया तो क्या हो गया नेगेटिव. सो P external is equal to P minus dP. Clear? So this is equation number 2. From equation 1 and 2, we are placing dW as it is, dV as it is. Only P external is nothing but P minus dP, minus sign as it is, P minus dP. After that, dW is equal to, after solving, minus P into dV, minus P into dV, minus minus plus. So dP into dV. This is equation number 3. As you know that dP and dV are very small because it's a reversible process. In reversible process, driving force and opposing force are infinitesimally greater. That's why dP is very small, dV is also very small. That's why it can be neglected from equation number 3. Therefore equation 3 बन गया, dW is equal to minus P into dV. ये टर्म बहुत छोटी होने से वजह से हमने निगलेक्ट किया. उसके बाद क्या बचता है, dW is equal to minus P into dV. हमको इसको डिराइव करना है. कैसे? मैक्सिमम वर्क के लिए डिराइव करना है. मैक्सिमम वर्क के लिए डिराइव अगर करना है तो उसका इंटीग्रेशन करना पड़ेगा. इंटीग्रेशन करना है तो लोअर लिमिट V1 रहेंगी वॉल्यूम की और अपर लिमिट क्या रहेंगी V2. सो इंटीग्रेशन ऑफ dW माइनस साइन, इसका इंटीग्रेशन नहीं हो सकता इसलिए आउटसाइड इंटीग्रेशन, लोअर लिमिट V1 अपर लिमिट V2, P into dV. But you know that pressure, we want a derivation of P according to ideal gas equation. PV is equal to nRT. Therefore P is equal to V, denominator में आ गया nRT upon V. So this is equation number 6. From this equation we can write the dW, integration of dW minus outside integration V1 upon V2. यहाँ पे क्या था P की जगह क्या आ गया nRT upon V into dV, जैसे के वैसे. फिर उसके बाद नंबर ऑफ मोल्स ऑफ गैस चेंज होंगे क्या? नहीं, वो कांस्टेंट है. गैस कांस्टेंट R वो भी कांस्टेंट है और आइसोथर्मल प्रोसेस होने की वजह से टेम्परेचर भी क्या है कांस्टेंट है. ये तीनों टर्म कांस्टेंट है इसलिए इंटीग्रेशन के बाहर आ गए. सो W मैक्स इंटीग्रेशन ऑफ dW क्या आ गया W मैक्स माइनस पहले से n आ गया R आ गया T गया nRT. इंटीग्रेशन व्हाट इज रिमेनिंग dV अपॉन V. उसके बाद इसको सॉल्व करेंगे. इंटीग्रेशन ऑफ dx अपॉन x log ऑफ x. तो इंटीग्रेशन ऑफ dv अपॉन v log ऑफ v. लोअर लिमिट क्या आ गई v1, अपर लिमिट v2, बाकी का जैसे के वैसे. तो w max माइनस nRT log ऑफ अपर लिमिट v2 माइनस log ऑफ लोअर लिमिट v1. उसको सॉल्व किया w max माइनस nRT log v2 अपॉन v1. अब जो log का बेस है, log क्या है बेस टू द e है, इसको हमको 10 में कन्वर्ट करना है. जब log का बेस e रहता है उसको 10 में करना है तो उसको 2.303 से क्या करते हैं मल्टीप्लाई. ये माइनस साइन वैसे ही है 2.303 आ गया माइनस nRT जैसे के वैसे. log टू द बेस ही है, इसका क्या आ गया log टू द बेस 10 V2 अपॉन V1 जैसे के वैसे. ये हो गया अपना इक्वेशन नंबर 7. हो गया. ये किससे रिलेटेड है? वॉल्यूम से रिलेटेड है. हम प्रेशर से रिलेटेड इसको डिराइव कर सकते हैं. We know that at constant temperature P into P1 into V1 is equal to P2 into V2. इसको इंटरचेंज करेंगे. ये V2 इधर आ गया तो V1 के नीचे आ जाएगा, P1 इधर आ गया तो P2 के नीचे आ गया. इसका मतलब क्या हो गया V2 upon V1 is equal to P1 upon P2. Putting this value in equation 7, what you are getting? W max is equal to minus 2.303 nRT log to the best. And V2 upon V1 है, V2 upon V1 क्या होता है P1 upon P2. यह हो गया उसका डेरिवेशन. It is very important for examination point of view for 2 marks or 3 marks, or it is also important for solving the numericals. After that we are taking the derivations. After that we are going for numericals. For numerical point of view this derivation is very important. You have to memorize it. So this is our derivation. So now we'll stop here. We'll continue for next video. तब तक के लिए bye bye.